Welcome to Module 9. Throughout this course, we've learned about the science of climate change, the range of observed and predicted impacts, and the strategies that have been developed to reduce greenhouse gas emissions and help to mitigate climate change. But we've also learned that some degree of climate change is actually inevitable, even if we magically reduce our emissions to zero tomorrow. This means that we have to prepare and protect communities and the planet's ecosystems from the impacts of climate change. This is the domain of adaptation. First, we'll run through a refresher of the main concepts that we were introduced to in Module 7. Next, we'll be introduced to adaptation, especially as it differs from mitigation, before taking a look at the range of human experience with adaptation. Transcending the history and future of human adaptation to climate are the ideas of proactive versus reactive adaptation, which we'll be exploring here as well. If you've been feeling like the definitions of core adaptation concepts tend to blend into one another, you wouldn't be alone. To clear up a bit of the muddiness, we can clarify the definitions that are the most widely held in the climate change community. You might remember from Module 7 that vulnerability to climate change impacts represents the convergence of exposure to impacts and sensitivity to them. Adaptive capacity, which is most commonly used to refer to human systems, is comprised of financial resources, technological resources, human capital, such as education, and social capital, the networks of trust and collaboration among groups. Finally, resilience is the amount of give in a system. In other words, how severe can the impacts be before the system is fundamentally altered? Adaptation is a set of responses that help to reduce vulnerability and enhance resilience. Adaptation to climate change is generally thought of as a way to manage the risks associated with climate change impacts. As such, experts in this field often specialize on disaster management, risk perception, geography, related fields like urban planning, and ecology. A common distinction between adaptation and mitigation may in fact be a false one, but it's often said that adaptation is essentially local in focus, while mitigation is global in focus. While it is true, generally speaking, that the benefits of erecting a flood protection system, for instance, only protects those people in the nearby floodplain, we've also seen how the impacts of climate change can reverberate around the globe. Carrying this example forward, if the dike isn't constructed, this vulnerable population loses their homes and livelihoods, and they may become environmental refugees. This can have a really severe impact on safe places or nations that are close by. Similarly, mitigation is generally thought of as global in focus when compared to adaptation. Emissions reduced in any location mix in the atmosphere and affect the global climate equally. But mitigative responses are also designed, implemented, and paid for locally. Mitigation has an impact on local communities, and it can also yield co-benefits like improved air quality. Adaptation experts have found that adaptation to climate change is best implemented if it's integrated into already existing programs like city planning, development aid, or ecological conservation. Actions that we're taking for other reasons may be shifted slightly to account for predicted climate change impacts. But as we'll see, humans have extensive experience with adapting to the vagaries of climate. Adaptation experts delineate clearly between reactive and proactive adaptation, in part to identify the ways in which we have to advance our knowledge and practice to address a potentially unpredictable future. Adaptation can be viewed as reactive in either stimulus or form. By stimulus, we mean the driving force behind the adaptive action. If we observe that water is becoming more scarce, we can develop irrigation systems that address the problem, for instance. Adaptation that is reactive in form refers to actions that don't actually prevent the impact from occurring, but help us recover after. Insurance is a really good example of adaptation that is reactive in form because it helps compensate victims of climate change impacts, but doesn't protect them physically. Generally speaking, reactive adaptation is informed by direct experience rather than by predictions or forecasts. The benefit of this is that it's often quite clear how resources should be used to protect against the impacts, and so uncertainty is pretty low. Reactive adaptation is very familiar to humans, and we've been doing it for thousands of years. There are many good examples of reactive adaptation to climate throughout our history. Crop diversification, irrigation, and water management, for instance, have been common in agrarian societies since the development of agriculture nearly 10,000 years ago. By 5000 BC, Sumerians had developed large-scale, intensive cultivation of land and organized irrigation. Archaeological investigation has identified evidence of irrigation in Mesopotamia, Egypt, and Iran as far back as the 6th millennium BC, where barley was grown in areas where the natural rainfall was insufficient to support the crop. More recently, we've developed reactive adaptation practices like disaster risk management. This helps communities recover from and prepare for extreme weather events. Insurance, as I mentioned, is another more recent example of reactive adaptation to climate. We're only beginning to integrate predictions based on our understanding of anthropogenic climate change into our insurance schemes, which would then be considered adaptation that is proactive in stimulus, but reactive in form. If you're looking for more information about this, the reinsurance companies Munich Re and Swiss Re do really interesting work on calculating the risks associated with extreme events and climate change. Proactive adaptation is the ultimate goal of the climate change research and practice community. Adaptation is proactive in stimulus if the driving force behind the action is the prediction or expectation of events that we haven't experienced yet. It's proactive in form if we take steps to prevent the impact from taking a toll in the first place, such as flood protection infrastructure. Proactive adaptation is much more complicated than reactive adaptation because we're only beginning to understand the climate change impacts that we expect to see in coming decades. Our information is constantly improving, but infrastructure decisions depend on accurate information about the extent, the timing, and distribution of impacts. Without this information, it can be really difficult to build a case for new flood management strategies or approaches to city planning. So proactive adaptation is the frontier of climate change responses, and it requires significant advances in the science of climate change. Although humans do have experience with adapting to climate change, we're now seeing that anthropogenic climate change is pushing us outside of our comfort zone. Not only are droughts and heat waves more extreme in many places than we've seen in the past, we're also seeing new impacts like rising sea levels and increased unpredictability of extreme events. Compounding these challenges is the fact that we've built massive infrastructure and huge cities in vulnerable places. So our ability to proactively adapt to climate change is constrained by our knowledge of the phenomenon of climate change, as well as the political will to take precautionary action and the public's perception of the risk. Partly as a result of this, adaptive actions are rarely taken in response to climate change alone, but rather in response to a constellation of impacts and vulnerabilities. This lecture has provided an introduction to adaptation to climate change. Although humans have a long history of adapting to climate, this adaptation can generally be viewed as reactive, at least in stimulus. In other words, crop diversification, irrigation, and flood protection schemes have traditionally been based on what we know about climate in the past, rather than in the future. In a changing climate, though, these assumptions might not hold. So we look to proactive adaptation, which consists of responses to predicted impacts and ideally prevents the worst of the impact rather than just helping us to recover once it's already occurred. In the next lecture, we'll delve into specific adaptation strategies and discuss a couple of examples of places around the world where these are happening already.